Hello. The following example is the first example from Chapter 2, Section 7. I want to start out by talking about parent functions. Parent functions are effectively the simplest form of a function that you can have, where whenever you graph the function, it retains the same basic shape. I want to start out by talking about polynomial functions. So let's start out with the polynomials. The easiest one you can think of for a polynomial would obviously be the horizontal line. So y equals k. Now that's too easy. So we're going to go on to the linear ones. And those look like y equals x. Now y equals x is the polynomial that looks like this. Just imagine a coordinate grid there, and that's what it looks like. Now, we also have the quadratic, that is y equals x squared. Notice that y equals x is just the simplest form of a line, and y equals x squared is the simplest form of a parabola. I'm going to go ahead and graph the parabola like this. Something like that. Now, I want to talk about the domains and ranges here. So the domain for y equals x is all real numbers, and the domain for y equals x squared is all real numbers, because they're polynomials. The ranges, however, if you look at y equals x, that is all real numbers, but if you look at y equals x squared, that is 0 to infinity. I want to talk about the table. For tables, whenever we start talking about tables to graph stuff, what we really want to do is we want to have enough points to figure out what the graph is going to look like. So what we need to do, at least for the linear one, I can start out with x being -3, or -2, or -1, or 0, or 1, or 2, or 3. Basically, I just want some representative points to the left and right of 0, and 0 is usually a pretty good number to go around, simply because a lot of things happen around 0. So if we plug in -3 into this function, y equals -3 is what I get. So y would be -3 there. Then if I plug in -2, I get -2, and so on and so forth. Look at y equals x squared. The parent function we need to look at. Again, we want to go to the left of 0 and to the right of 0 because the domain is all real numbers. So I'm going to start with -3 again, -2, -1, 0, 1, 2, and 3. The y values, if you plug in -3, that gives me 9. Plug in -2 gives me 4. Plug in -1 gives me 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Notice that this is symmetric about 0 here. Everything to the left of 0 on the y is the same thing as everything to the right of 0 on the y. We can also go to higher degrees. We can go to y equals x cubed. Now, if I was to graph y equals x cubed, here's what it would look like a little bit. It looks kind of like a weird S whenever you graph it. And again, I could do an XY table. And start with -3, -2, -1, 0, 1, 2, and 3. For polynomials, I generally like to use -3, -2, -1, 0, 1, 2, and 3. But as you see for y equals x cubed, that's actually a little bit too far on the x-axis, because if you plug in -3 cubed is -27. -2 cubed, however, is -8. And -1 cubed is -1, 0, 1, 8, 27. Now notice that although they're the same numbers to the left and right, to the left it's negative and to the right it's positive, and that's because it's cubed. And we could go to the 4th power and 5th power and 6th power and so on and so forth. but these are the parent functions for the polynomials. I'm going to go ahead and stop here, and when we come back we will talk about the parent functions for everything else that we're going to talk about, or at least what we're going to talk about in this chapter.